Time travel. Just hearing those two words is enough to spark the imagination. We picture DeLoreans, TARDISes, and swirling wormholes. The idea of leaping forward into the distant future or stepping back into the past to change history is one of the most captivating concepts in science fiction. But is there any truth to it? Could time travel actually be real? Not just in the movies, but according to real hard physics? Well, buckle up, because the answer isn't a simple yes or no. Time travel is one of those rare topics where science fiction overlaps with actual science more than you might expect. It turns out that modern physics doesn't entirely shut the door on time travel. In fact, under the right conditions, it might even allow it. Let's start with what we know for sure. Time is not absolute. That's not just a theory, it's a fundamental part of how the universe works. Thanks to Einstein's theory of relativity, we know that time flows differently depending on how fast you're moving and how much gravity you're experiencing. This is called time dilation, and it's a well-tested, measurable effect. Imagine two twins. One of them stays on Earth, the other boards a spaceship and travels near the speed of light. When the spacefaring twin returns, they will have aged less than the one who stayed home. It's not magic, it's just how time behaves at high speeds. This is real, and it has been confirmed with experiments involving precise atomic clocks flown in jets or placed in different gravitational fields. Even astronauts aboard the International Space Station age slightly slower than we do down here on Earth. They're literally time travelers by fractions of a second. So yes, in a very real sense, traveling forward in time is possible. We just don't notice it because the differences are so tiny. But if we could travel fast enough, say 99.9999% the speed of light, those effects would grow dramatically. You could go on a spaceship journey that takes only a few years from your point of view, but when you come back, decades or even centuries might have passed on Earth. That's not science fiction, that's relativity. But of course, when most people think about time travel, they're not thinking about going forward, they're thinking about going back. That's where things get complicated, because while relativity allows time to stretch and compress, it doesn't easily let it reverse. One of the most famous obstacles to backward time travel is the grandfather paradox. Let's say you go back in time and accidentally prevent your grandfather from meeting your grandmother. Then your parent is never born, and neither are you. But if you never existed, how could you have traveled back in time in the first place? This kind of logical contradiction makes physicists nervous. It breaks something fundamental called causality, the principle that causes must come before effects. However, some solutions in general relativity, the part of Einstein's theory that deals with gravity and the shape of space-time, do allow for strange things called closed timelike curves. These are loops in space-time that, theoretically, could let you return to an earlier point in time. The mathematics checks out, but to actually make one of these curves in the real world would require some extreme ingredients. You'd need massive rotating objects, or perhaps wormholes, tunnels through space-time that connect distant locations, or possibly different times. Now, wormholes are where time travel really gets exciting. A wormhole is a hypothetical tunnel with two ends located at different points in space and time. If you could keep it stable, and that's a big if, you might be able to use it to travel from one time to another. But there's a catch. Wormholes are incredibly unstable. Any attempt to pass through them would cause them to collapse almost instantly. To keep one open, you'd need something called exotic matter, which has negative energy density, a substance we've never actually observed in large amounts. Even if we did figure out how to create or find such exotic matter, building a stable wormhole would be an enormous challenge, way beyond anything current technology can handle. Some theories even suggest that the moment you try to use it to travel into the past, some quantum effect would intervene to destroy the wormhole, protecting the timeline from paradoxes. This idea was proposed by Stephen Hawking and is known as the chronology protection conjecture. It's like the universe has its own built-in defense system against time travel to the past. But things get even stranger when you bring quantum physics into the picture. At the quantum level, the level of atoms and particles, the rules are weirder. Some physicists have proposed that if you travel back in time, you might not actually change your own past, but instead create a new timeline. a parallel universe that branches off from your own. So even if you do stop your grandparents from meeting, you don't erase yourself. You just create a version of reality where you were never born, while the original timeline remains unchanged. This is sometimes called the many worlds interpretation. It's highly speculative, but it offers a potential way around paradoxes. Instead of one timeline that can be messed up, there are infinite timelines, and time travel simply moves you from one to another. It's like switching lanes on a cosmic highway rather than turning around and driving backward on the same road. So where does this leave us? Here's the truth. Traveling to the future is allowed by physics. It's already happening on small scales. And if we could build faster ships or orbit powerful gravitational fields like black holes, we could do it on larger scales. Traveling to the past? That's murkier. The equations don't strictly forbid it, but every method we've thought of so far runs into huge problems. Logical, physical, or technological. But perhaps the most mind-bending idea of all is this. Maybe time itself isn't what we think it is. Some physicists believe that time is not a fundamental part of reality, but something that emerges from deeper physical laws we don't fully understand yet. If that's true, then asking whether we can travel through time might be like asking whether we can travel through temperature. It might not make sense in the way we imagine it. For now, time travel remains one of the greatest mysteries in physics. It's tantalizingly close in theory, but maddeningly far in practice. Maybe one day we'll unlock the secrets of space-time. Or maybe we already have, and our future selves are watching this video from the past. Either way, time travel is one of those rare places where physics dares to dream as wildly as our imagination. And that alone makes it worth exploring. If you found this fascinating, make sure to hit that like button and subscribe. And tell us in the comments, if you could time travel to any moment, past or future, where would you go?